So today we're going to do some synthetic division or division of polynomials, and synthetic division in particular is a shortcut that we can use when we are dividing polynomials. So way back when you had a division algorithm, and let me just run you through a long division problem for a second. Old school math, like if I wanted to do 765 divided by 3. You would say 3 goes into 7 2 times. Then you do 3 times 2 is 6, and you'd subtract, get a 1. Then you would drop down the 6. 3 doesn't go into 1, so 3 has to go into 16. 3 goes into 16 5 times. 5 times 3 is 15. Subtract 1. 3 doesn't go into 1, so then you bring down your 5. 3 goes into 15 5 times. And actually, let me just change this real quick. Let me change this 5. Let me make this a 7. So instead of doing 365, instead of doing 765, I'm gonna do 767. So if I brought down a 7 and asked how many times that 3 went into 17, you would say 5. 5 times 3 is 15, subtract, and that 2 right there is what you called remainder 2, or you could write 255, and then 2 was the remainder over 3, what you divided by, so in 2/3. So what we're going to do is we're going to do a very similar algorithm, but a shorter way to do it. So let me do a problem so you can see the pieces, and then I'm going to label them. And I'm going to label some of them along the way. So first of all, this thing that I'm dividing into, much like my 767, this is called the dividend. The thing I'm dividing by is called my divisor. If my divisor is linear, meaning no squares or anything of that nature, which this one is, then I can use the shortcut thing called synthetic division. Before you do any kind of polynomial division, synthetic or long division, we need to check 2 things. There's 2 key rules. And the rules have to do with the dividend. So my rules that have to do with the dividend are 1, is it in order? And what I mean by in order, is it in degree or power order? So this goes 3, 2, there's a 1 there, 1, and then none. And number 2, if you have any missing terms, you need to add in a 0 for those missing terms as a placeholder. If you don't do those 2 things, it's going to be a nightmare. So we'll keep revisiting those rules. So if I want to do synthetic division and my divisor is a linear term, you take your divisor, my x plus 2, and I set it equal to 0. And I get out that x equals -2. So I call it a house. In my little house, I'm going to put my -2. That's what x equals. And then I'm going to write only the coefficients for the numbers. This is why it has to be in order. So my biggest power is 3. Its coefficient is 5. And then a -6, -28, -2. If someone was missing in here, you would have to put a 0 in as that placeholder. So you drop the first number down, the 5. Above the line, we're going to add, and below the line, then we're going to multiply. So I'm going to take my -2 from my house, and I'm going to multiply by 5. And when I do that, -2 times 5 is -10. Above the line, I add. So I'm going to add these 2 together right here. -6 plus -10 is -16. Then I multiply again, yellow line. -2 times -16 is going to make a positive 32. And then I add above the line. -28 plus 32 is a 4. I multiply -2 times 4 with that yellow line. And I'm going to get -8. And then -2 plus -8 makes -10. This thing at the end right here is my remainder. And if I take this right here, this underlined piece, I started with an x cubed and I divided by a single x. So if I go down by 1 power by 1x, this blue underlined thing becomes 5x squared minus 16x plus 4. This piece right here is called my quotient. And then I have to write plus my negative 10 over my remainder over my divisor, which was x plus 2. So this whole greened box thing is the answer when you are asked to divide. So we're going to keep using that synthetic division to solve the next couple problems. So on the next page, it gives you the remainder theorem. It says, if the polynomial f of x is divided by x minus k, then the remainder is equal to f of k. So what that means is, if I put k in the house and do all my math, I'm going to write A, B, C, D, E, F, G, H, I, J, K, M. I'm going to skip Alex, it looks like a 1, M. So if I do all this math, and this is my synthetic division, then this is the same thing as saying f of k equals m, whatever your remainder was right here. So let's do that. It says that I'm going to use the remainder theorem, and I let my polynomial f of x equal what's typed on your paper or written on your page, and then use the remainder theorem to evaluate f of negative 3. So you put negative 3 in the house. Then before you write anything else, you should check this out. Is it in order? 4, 3. I'm missing the third power, and then 2, 1, 0. So when I go down here and write my numbers, I get negative 1. This was my x to the 4th. I have 0 x cubes. Negative 4. Nope, sorry, I skipped a number. Negative, not 4. Then I have 3 x squareds, negative 4 x's, and 5, negative 5. So then I draw my line. Remember, you drop the first one down, negative 1. Above the line, you add. Below the line, you multiply. Negative 3 times negative 1 is 3. 0 plus 3 is 3. Negative 3 times 3 is negative 9. 3 plus negative 9 is negative 6. Negative 3 times negative 6 is going to make a positive 18. Negative 4 plus 18 makes a positive 14. Negative 3 times 14 is negative 42. And then you add these two together and get negative 47. So f of negative 3 is equal to negative 47, whatever my remainder was. So if the directions say use the remainder theorem, this is what they need you to do. Continue with ideas of remainders. The next problems say they want me to find out if the thing they give me is a 0. So in this case, they've already solved. This was like saying x minus 1 equals 0. They add the 1 over x equals 1. They're already telling me this is my x value right here. This is what x equals. So I'm going to put 1 in the house. I'm going to write my coefficients and make sure they're in order, and then I'm not missing any. So I have x to the third is 1, negative 4x squareds, 9x's, negative 6. They're in order. No one's missing. Above the line you add, below the line you multiply, drop down the 1. 1 times 1 is 1. Negative 4 plus 1 is negative 3. 1 times negative 3 is negative 3. 9 plus negative 3 is 6. 1 times 6 is 6. Negative 6 plus 6 is 0. My remainder is 0. That's super important. Since the remainder is 0, comma, k equals 1, or, actually, k equals 1 is a 0 or a root, which also tells us that x minus 1, whatever the k value was, x minus 1 is a factor of f of x, that polynomial they gave us. Okay, let's try another one. Oh, actually, let me write it. Yes. It is a 0, and then I've explained it. Okay, on the second one, You're going to put the negative 1 in the house. X to the 4th is 1. I don't have an x to the 3rd. X squared is 1. X is negative 3. And then 1. So x to the 4th, x to the 3rd, x squared, x, and then no x's. Drop down the first one. Add and multiply. Negative 1 times 1 is negative 1. 0 plus negative 1 is negative 1. Negative 1 times negative 1 is 1. 1 plus 1 is 2. Negative 1 times 2 is negative 2. Negative 3 plus negative 2 is negative 5. Negative 1 times negative 5 is 5. 1 plus 5 is 6. No, it's not a 0 because the remainder is 6. The remainder has to be 0 for the thing that you're dividing by, the divisor, to be a 0. Okay, one more. Okay, this one looks a little different. I just need you to trust the process. It is not bad. It is not horrible. We're going to do it. Same question is this thing they give us a 0? And that is still a linear term. There's no squares or anything, so I can still use synthetic division. So in my house, I'm going to put my whole thing, 1 plus 2i. I'm going to write my numbers out. 1, negative 2, then a 4, then a 2, and then a negative 5. So we're going to drop down the 1. We're going to multiply below the line. So 1 plus 2i times 1 is going to be 1 plus 2i. And now we still add, but I'm going to add the real piece with the real piece. So negative 2 plus 1 is negative 1 plus 2i. And now I'm going to actually have to multiply. I'm going to multiply 1 plus 2i times negative 1 plus 2i. So 1 plus 2i times negative 1 plus 2i. We're going to follow those together. So 1 times negative 1 is negative 1. 1 times 2i is 2i. 2i times negative 1 is negative 2i. 2i times 2i is a plus 4i squared. I squared is negative 1, so this piece is really a negative 4. 1 and negative 4 make negative 5. And then these two, 2i and negative 2i, cancel off. So those multiply together make negative 5. 4 plus negative 5 is negative 1. Negative 1 times 1 plus 2i is negative 1 minus 2i. Again, you're going to add the real with the real. So you're going to get 1 minus 2i. And now I have to FOIL. 1 plus 2i times 1 minus 2i. 1 times 1 is 1. 1 times negative 2i is negative 2i. 2i times 1 is 2i. 2i times negative 2i is negative 4i squared. The i's are going to cancel, or the 2i and the negative 2i cancel off. I squared is negative 1, so this is really a plus 4, so this becomes a 5. And then when you add those together, remainder of 0. So yes, this is a 0 of this polynomial because my remainder was 0.